Hey, what is up, guys? So today we're going to be looking at this Gigabyte RTX 3080 Ti. This is the Vision OC edition, and for the first time in a long while we have a Gigabyte card that's come in, and it doesn't have the typical crack on the locking tab. These are quite rare. We have noticed that it does have a sealed sticker on it. This doesn't necessarily mean it hasn't been opened. These stickers are available if you know where to look, and there's a lot of fishy people out there that'll actually apply one and sell a repaired card as new. It's not the first time we've heard about that. So anyway, there's a note with this. The customer has reported that this card failed in game. He rebooted it and it failed a second time, and when he tried it a third time, the card's now not displaying anything. So we're going to get it under the microscope, take a better look at the board, and see what we find inside. Right, so here's our card now in a stripped down state. We've given it a bit of a clean. We're now going to do all the base voltages and resistances and see if we can find anything that's out of the ordinary. Okay, so starting in diode mode, checking the first data pair. They're both good. Checking the ref clock plus and minus. They're both good. All right, so checking in, we'll go full resistance mode, 12 volts from the slot. 2 kilo ohm and rising, which is normal. 3.3 volts. That's perfectly normal. Checking the external 12 volt rails. Let's check from the fuse. And we have a short circuit. Okay, moving on, checking the other 12 volt rail. 1 kilo ohm, 2 kilo ohms, yep, and rising, perfectly fine. 5 volt rail. 1.7 kilo ohm, that again looks perfectly normal. Checking 1.8 volts. Looks normal to me. Checking PIX. And that's perfectly normal. And checking memory. Yeah, perfectly normal for this. So we have to address this short circuit now. What we'll do is we'll get it under the microscope. We'll have a look at all the power stages. Usually when we have a 12 volt short circuit, it's one of the power stages that die. So we'll get it under the microscope now and we'll inspect in the area, see if we can find any damaged components maybe, or even any of the power stages themselves that are faulty. Alright, so here we have it under the microscope, and we're just going to go over these power stages, see if there's anything obvious. And we have a bit of a mess. Let's give that a bit of a clean. Okay, so there's nothing obvious under the microscope. We're going to have to inject some voltage down this rail and see if we can identify the problematic one. Alright, so we're all set now to inject voltage and take a look. You may notice we have the multimeter out, so when we're injecting voltage, we actually have our DC meter set to 1 volt. And we use our probe on the multimeter to actually check this, so we can see there's 1 volt. This gives us a good idea of the voltage draw actually being pulled. So we're just going to stick it on the fuse where the short is. And you can see it's dropped to 0.6 volts, and it's pulling 2.7 amps right now. And we're just having a look on the board if anything gets warm. We have some subtle heating over there. It looks like that might be our problematic stage. Not sure if you can see that on the camera, probably not. Let's see if we can clean up the view. Okay. And we have it right there. So voltage off and voltage back on. Can you see that red spot coming and going? Clear indication. Okay, so that's our third power stage done. I'd just like to mention here that for anyone who repairs these and doesn't have the luxury of a thermal camera, when we were actually checking this did catch my attention right here. As small as this is, it's actually, oh no, it's actually a lot worse than I thought. That is some solder balls which have come off. See, so this was actually a indicate that this was the problem of the phase. So those solder balls mean that this power stage is overheated and all the solder is actually melted under there. Oh, there's actually more on the side here, which I overlooked. So for anyone who doesn't have the luxury of a thermal camera, this would have been a dead giveaway. Right, so we're going to get it on the preheater now, warm the board up, and we're going to remove that. Right, so this is our faulty power stage. Right here, we've given it a wipe just so we can see the numbers, and this is what we're going to replace it with. So we're going to go ahead now and get that off there and switch it out. Let's see if our short is gone. Right, so this is our power stage that was shorted out. This has now been replaced. Everything's looking good over here. We didn't bump any components. They're all still in place. So we're going to go back over to this fuse now. And with the multimeter in, what we'll do is put it in beep mode. So maybe you can hear it. So if I touch ground, we have a beep. And we're going to check the fuse again. And we have no short at all. Okay, so our short's now been cleared. We will have to replace this fuse, and once we replace this fuse, we should be able to test the card again. So we're just going to warm the area here and apply a small amount of low melt solder from our soldering iron. This will reduce the melting temperature of the solder, and we'll be able to get this off at a lower temperature, and that'll stop us from damaging any of the plastic components that are around the area. Right, so here we're just going to clean up the pads with the solder iron. We have damaged a bit of the masking on the one pad. It won't cause any problems, so there was no need to fix it up. Okay, so checking again now with the multimeter. Full resistance mode, we now have 1.2 kilo ohms, 2 kilo ohms, 3 kilo ohms and rising. So this is now perfectly normal. Checking both sides. And that's absolutely perfect. Right, so as always, what we want to do now is plug in the card and test this phase to make sure the phase is switching correctly and it's not going to blow up as soon as we plug it in. Everything is looking good so far, so we're going to set up the cables right now and then take a look at that phase. Alright, so here's our card now set up. We're going to test the frequency on that face. You can do this with a multimeter in frequency mode. And we're just going to poke it on the switching side right here. And we're going to boot up the card and see if we get a switching frequency. And we do, 283 kilohertz, which means this card should be ready for testing because that phase is working correctly. So we'll put the cooler back on now and we'll switch over to testing. Alright, so we now have the card plugged in right here behind me, and we're going to power it on now and then see if we get an image out of it. And we have an image. So this repair is most likely good. We'll take it to the desktop now and finish up all the other checks we need to do and get it onto testing, and hopefully everything runs smoothly from there on out. Once again, if you learned anything or you just enjoyed watching the video, thank you, and you could like and subscribe. That would be great. If you're looking to get in touch with us and send us a card or a device of any sort for repair, you can contact us via our website at byorkgaming.co.uk. Thank you very much for watching.